Hey everyone, thanks for coming back for more. Hope that you have been finding these videos helpful. Today's just a review day, and you've got plenty of review work to work on. I think there's 3 sheets that I'd like you to complete today. And really the goal today is just to be able to organize all these formulas, because we have so many formulas now. And if you look over at the sideboard, they're all there for you, but you have to know how to use them. So let's just review them quick. Our first formula that we learned had to do with the sum of an arithmetic series. So we're just talking about the series formulas today, because those are the ones we've learned just this week. Last week we talked about recursive and explicit formulas for geometric and arithmetic, which I think we have down by now. But the series ones are kind of the new ones. So this first one is a sum for the first n terms of an arithmetic series. So the first n terms of an arithmetic series. And the things we have to know for that are the n, so we have to know how many terms there are, and we have to know the first term, and we have to know the last term. So those are kind of the important things there. I'm going to erase those so you can see a little bit better. The next one is just exactly the same formula. So this does the same thing, but we just substituted in for an. We use the explicit formula, which is a1 plus d times n minus 1. And they write it a little bit different than I have it up on the board, which is fine. So that's where we get the 2 a1s plus the d times n minus 1. But it's just exactly the same formula. Once again, I'll try to keep this clean so that you can see it. Next one is the sum for the first n terms of the geometric series. So first n terms, this will be of the geometric series. Geometric series. And so for this one, what you need to know is you need to know the first term, and you need to know the rate. And then you have to know how many terms you're summing up. All right, so that's how that one works. And this one we usually used when we had an r value. This is what we usually used when we had an r value that was less than 1. And then we have a very similar one that we usually use for when r is greater than 1. All we did was multiply the top and bottom by -1, which is fine. And now we're going to have positive values on the top and bottom, which is a little nicer. Then the last formula we learned this week, which you learned in the last video, was for an infinite geometric series. Infinite geometric series. And remember, what we had to know for this is that we have to have an r value where the absolute value of r has to be less than 1. So if you have a ratio where you're adding, or you're multiplying, every time by a number less than 1, so like maybe 1/2 or 1/3 or 1/5 or 5/6, I don't know, but something where it's less than 1, we can use this formula to say, hey, if I add up all of these terms together, all I need to know is g1 and r, which is pretty cool. We proved that using a limit statement. So with all of these formulas, it would be nice if we kind of had an organized way to be able to put all these things together. And that's kind of what this idea is of this first sheet that you have. So if you want to grab your sheet and actually do this problem with me, you're welcome to do that. This is in your blue packet. It's the first problem on the one that says partner worksheet for 8.4 to 8.5. Just a nice way to be able to keep your thoughts organized here. So let's see what's going on. A ball is dropped from a height of 54 meters. After hitting the ground, it rebounds 2/3 of the distance fallen and continues to rebound in the same manner. So I'm just going to kind of draw a picture up here. So the first drop is 54 meters. And then we come back up 2/3 of the way, and then we go back down that same distance. And then we come up 2/3 of that and come down the same distance, and this is going to continue. So this is going to continue on. 2/3 up, 2/3 down, 2/3 up, 2/3 down. So this is going to continue on until it comes to rest. Until it comes to rest. This means this is going to happen forever. Now, forever is kind of dramatic considering that it's going to come to rest, but it's going to keep bouncing 2/3, and we really don't know. I mean, if it's 2/3 every time, really, then it's going to stop. I mean, it's really never going to stop. It's going to keep bouncing 2/3, but 2/3 will be so imperceptible after it ends up looking like it's come to rest. But really, this is infinite. So let's think about this first. What are we doing here? Well, the first one is 54. The next one is going to be 54 times 2/3. The next bounce is going to be 54 times 2/3 squared. So it looks like we have a geometric series going on here. So this is a geometric series. This is why this box is nice, because it helps you organize your thoughts. It's a series because we want to add all those things together. I want to know the total distance traveled by the ball, which actually makes this problem a little bit complicated, because the first time I did this, I actually did it wrong. We'll talk about that in a second. And as we said, it's infinite. It's infinite because this bounce continues to happen 2/3, 2/3, 2/3, 2/3. It's never going to stop. And convergent or divergent? Well, we have a ratio that is less than 1, so we know that that's going to be convergent. So what do I know? Well, I know the first term is 54. 54. And then my constant ratio is 2/3. And really, that's all I need to know to be able to use the infinite formula. Now, my mistake I made the first time was that, okay, let's just throw this right into the formula. Infinite formula is g1 over 1 minus r. We saw that on our last slide. I think I still got it there, but I'm going to have to... Oh, nope, it's still here. So g1 over 1 minus r, that's for our infinite geometric series. So we know that's the formula we're going to use. And I said, okay, I'm just going to throw these in there, and I'm done. But look at this picture, and see if we can figure out what's wrong with that. It drops 54 meters. What this would do is it would just add one of these lines, but it has to come up and then it has to go down. So it has to come up and then go down, and then up and down. So each of these distances after 54 actually happens twice. It actually happens twice. Now, there are lots of ways you can deal with that. One way is you could just add the series together twice, which is the way we're going to do it, and then we count the 54 too many times there, so we'll have to subtract it. We'll talk about that in a second. Another way you could do it is you could say, okay, well, what I want here is I want to do 54 plus... Now, the next one's going to be 54 times 2/3, but I need that twice, so I put a 2 in front of that. Then the next one will be 54 times 2/3 squared, and I need 2 of those as well. You should have a 2 in front of all these. Then you can factor out the 2 and actually just look at the series starting at this first one, which has a first term of 36. We're not going to do it that way, so I'm actually going to erase it. But that's just another way you could do it. I just wanted to show you how you could do that. So the way we're going to do this is we're going to say, okay, you know what? Let's just assume that we only want the ups. Or let's say we only want the downs. Let's say we only want the downs. So all the ones that have the down arrow we want. So it's going to be 54, then 2/3 of 54, then 2/3 squared times 54, then 2/3 cubed times 54. And then we're actually going to be able to just plug these right in. So what are we looking for? We're looking for S infinity. We want to know the total sum of all of those things. So what we have here is g1, which is 54, divided by 1 minus r, 1 minus 2/3. So that is 54 over 1/3, which is just 54 times 3, because we can multiply by the reciprocal, which is 162. Now, originally, like I said, I stopped there. But, again, all we have now are all of the downs. So what we can do is multiply this by 2. So we do 162, and we multiply it by 2. Let's see, math in my head. That's 324. Oh, maybe better to do a calculator on that. Let's see, 162 times 2. Yeah, 324. Good, thank goodness. All right, so we've got 324 there. But like we said, that would only be assuming that we had this 54 happen twice as well. But it didn't. The 54 only happened once. So we have to do is subtract 54 from that one. And that ends up giving us 270 meters. Now, this one was a tough problem. I wouldn't expect you to have to do this multiplying by 2 mumbo-jumbo down here. I would just expect you to be able to use this formula. So you have to identify, okay, I'm looking for an infinite geometric series, and then be able to plug in the pieces to be able to get that answer there. So this is a nice organizational method just to say, hey, what am I looking for? How am I going to find that? What formula do I need? What do I know? That kind of leads you in the right direction of which formula to use. And then after you have all of this information in here, that's when you actually go and calculate out your solution. Because otherwise it's just like, man, I've got like 20 formulas and I don't know which one I'm going to use. And that can be kind of frustrating if you're trying to figure it out. So that's all I've got for you today in terms of the video. The rest of the hour is yours to work on those worksheets. So do all the ones that have the box like this. And then there's also a worksheet called, I think it's Review 8.4 through 8.7, which is a really, really good review to do for the quiz. So make sure you take a look at that. All of those solutions are online on Moodle. And if you have any questions, please email me. I will be checking my email, and I'd be more than happy to answer any questions that you have. I love you guys. That's why I'm here. Have a great day.